Okay, let me continue. Somebody please type the question in the group chat. Well, in this Zoom chat. Okay, Tanya, please. Thank you. Can you see that? Oh my, it's so blurry. Okay. Nope. Can you see that clearly? Yes, no.
Yes, miss.
I could send you a picture of the question after. Well, I'm going. We'll figure it out. We'll figure it.
Or you can send it in the group, miss.
Yeah, I'll send it. Let me just go
The
through this.
questions. Okay, that
Yeah.
will be good.
Okay. So, yeah, this whiteboard thing, not very familiar with it. So bear with me. Anyways, this question was a bit different. Hold on. Sorry about that. I think of that. Bro. Anyways, this question was a bit different from the example that I showed you and then that first question. How exactly is it different? Well, when you apply the rule, right, for equal vectors, x1 is equal to x2, y1 is equal to y2, you're going to get two equations, right? Just like before, you got two equations. But here's the problem. You have two variables in this equation. But before you only had one variable. So let me just give you an example. Before you had like 2x minus 2 is equal to 1. So it was easy, just transpose, find the value of x, right? It's not as straightforward here because you have two variables, x and y, in both equations. So how exactly are you going to find the values of these variables? So you see, whenever you have two equations and you're required to find, whenever you have two variables and you're required to find the values of each, you applied, substitution or elimination. Sometimes, like this question, you're basically given the two equations, right? But other times, you actually have to, pull information from the question and create your two own equations. When we move on to other topics, you'll see what I mean, right? Because sometimes it's not really straightforward. You would know, okay, I need to find the values of these two variables, but what two equations am I using? Sometimes you need to find the two equations, right? In this case, it was kind of straightforward. They basically gave you the two equations. So how are we going to do this? Substitution or elimination? I can do the both for you. So let's do substitution first. So I'm taking equation 2 and I want to make x the subject first. So y plus 5. Then taking this value, well, this expression for x, so the y plus 5, I'm then going to substitute it into the first equation. So this would become 3. Instead of putting x, I'm going to replace it with the y plus 5. So 3, but bro, don't start. Do not start. Plus, that's a bracket, okay? Bear with me. Y plus 5 plus y, and this is going to be equal to 2. It's simple from here because I only have one variable in my equation now. So all I need to do is transpose. So simplify a little bit, make y the subject, find the value of y. So this would be 3y plus 15. How did I get that? I just expanded these brackets, right? So using distributive law, 3 by y would give me 3y. 3 by plus 5 would give me positive 15. I still have my plus y here, and this is going to be equal, this is going to be equal to 2. Just ignore this little thing there. I'm not about to erase it. So 3y plus y, that would give me 4y plus 15, and this is going to be equal to 2 minus 15 from both sides. So 4y is going to be minus 13, but I don't want 4y, I just want y. So what would I do? Divide both sides by 4. So therefore y has to be equal to negative 13 on 4. or like somebody else did, they put it as the decimal, which was negative 3.25. In this case, it's acceptable because that's an exact decimal. But if it's not an exact decimal, leave it as a fraction, right? So in this case, the answer, negative 13.4 or negative 3.25. But you don't just stop there, right? That's the value for y. How do we find the value for x? Well, now that we know the value of y, I could substitute it back into this equation to find my value for x. So let me use a different color. Can't really see that. Green. So just ignore this. X. So we're trying to deal with this equation here, right? So x is equal to
Miss,
y.
why is it, excuse me, miss, why is negative 13, miss?
Because 2 minus 15 is negative 13.
Oh,
Do you understand that? I subtracted 15
yeah,
from both sides.
yeah.
Okay. So dealing with this equation right here, x is equal to y plus 5. But instead of putting back the y, I now know that the value of y is minus 13.4. So x is equal to minus 13.4 plus 5. And when you simplify this and all that, you're going to get 7 on 4. 7 on, yeah, 7 on 4, right? 7 on 4. So these are your two answers using the substitution method. Y is equal to minus 13 on 4, and x is equal to 7 on 4. Everybody good with that?
Yes, miss.
Yes, miss. Brilliantly explained.
Yes.
So that was the substitution method.
Yes, miss.
I've never heard that voice before. Who's that? Oh, was that you? I don't know. Anyways, let's just move on. Wait. Anyways, that was substitution. What about elimination? So substitution, elimination, it's whatever you prefer, right? If you choose to do substitution method, that was it. Elimination method now. So what's the purpose of the elimination method? Well, the purpose of that method is to eliminate or cancel one of the variables, right? So we would only remain with one variable in our equation. That's the whole purpose of this elimination process. So let's say, how do you get back everything? Wow. Anyways, so let's say I wanted to eliminate the y's. So I chose to eliminate the y's from both equations. What do I have to do to eliminate the y's? I would have to add in this case, because y, positive y, plus negative y is going to give me 0. Hence, the y's cancel, right? And that's the whole purpose of this elimination process. So I'm adding these two equations. 3x plus x is going to be equal to 4x. Like I said, the whole purpose was to eliminate the y's, right? So positive y plus negative y is going to be equal to 0. So I successfully eliminated that variable. Now it's 2 plus 5, which would give me 7. And from here, because I only have one variable in my equation, I could find the value of that variable. I just divide both sides by 4 because I want x by itself. So x is 7 on 4. Now that I have my value for x, I could substitute it into either one of these equations to find the value of y. You should get the same answer if you choose this one or if you choose this one, right? Looking at these two, I would prefer this one just because this one in this first equation, I have to multiply it by 3, which I don't really want to do. So just use the second equation, right? But like I said, your preference, you would get the same answer. So dealing with this second equation here, x I now know the value for that is 7 on 4 minus y is equal to 5. Minus y would be equal to 5 plus 7 on 4 minus y. Somebody tell me what's 5 plus 7 on 4. Come on, this isn't for me, this is for you. Not plus, minus, love.
5 minus 7 over 4 would be 13 over 4.
Yeah. 13 on 4. But of course, we don't leave it like this, right? Because we don't want negative y. We want the value of positive y. So therefore, this is very annoying. What am I supposed to do with this? So y, if I divide both sides by -1, y would be equal to negative.
Miss, if we had
Huh?
multiplied by negative on both sides, that would still be correct, right?
Multiply by negative
I said-
-1.
Yes.
Well, yeah, that would successfully get rid of this
Okay.
sign. So yeah. So yeah, that's the elimination method. You realize you get the same values for x and y. X is 7 on 4, y is minus 13 on 4. But like I said, I just preferred to eliminate the y variable because I didn't really have to manipulate anything, right? But let's just say you wanted to get rid of the x in these two equations. So we know elimination method, the purpose of it is to get rid of the variable, right? So let's say I wanted to get rid of x instead. Then I'll have to multiply this entire equation by 3 first to get, so just cross on this, 3x minus 3y, which is going to be equal to 15. So now I could eliminate these variables. What operation do I have to do to get rid of these two variables right here? I would have to subtract. 3x minus 3x would give me 0. So I successfully eliminate this variable right here. And what I would remain with is y minus negative 3y, which would be 4y. 2 minus 15 would give me negative 13. And from there, because I only have one variable in my equation, I can then say y has to be equal to negative 13 on 4. Then, just like we did just now, you take this value of y, substitute it into either one of your equations, get the value of x. You would get the same answer. Everybody good with that?
Yes, Miss Crystal.
Okay. I didn't even see any of them. Okay, I'm clearing this now, right? Is that okay?
Yes, Miss, that was very okay.
Yes, miss.
Okay. Mhm. So that was that whole thing there. We found the values of x and y. So that's the end of equal vectors, right? It was just that simple. But the x component of one vector equal to the x component of the other, y component of the first vector equal to the y component of the other. It's just that simple. On to scalar multiplication. Scalar, when I say scalar, I just mean like a constant value, right? You see what I'm talking about. So consider a vector A, and they told me that the column vector for this vector is 3, 4. If I told you to find the magnitude of this vector, aka the length or modulus or size, hold on. Anyways, I'm still anyways. Okay, sorry about that, right? Something distracted me. Okay, so if I ask you to find the magnitude of this vector A, you would do what I told you to do, right? So it's the square root of the x component squared plus the y component squared. X, remember, x is always on top. So your column vector is in the form x, y, right? To find the magnitude, it's always the square root of x squared plus y squared. So in this case, x would be 3 because that's the number on top. So 3 squared. Y is the bottom number, so it's 4 squared. So to find the magnitude of this vector A is the square root of 3 squared plus 4 squared. Simplifying this a bit, 3 squared is 9, 4 squared is 16. 9 plus 16, 25. The square root of 25 is 5 units. That's my magnitude, aka the length, or the modulus, or the size of this vector A. Then if I ask you to find the direction of my vector, because remember, the definition, like the basic definition of a vector, is a quantity that has both magnitude and direction, right? So I just found the magnitude. If I ask you to find the direction, that we did that before, right? It's tan theta is equal to y on x. Y, which is always the bottom number, is 4. So tan theta is 4 on 3. Why 3? Because the x is 3, right? The number on top, 3. So tan theta is equal to 4 on 3. Tan inverse of 4 on 3 would give me my value of theta, which is 51.3 degrees. So that's the direction of this vector, the angle that it makes with the x-axis. So this might look like, let's say this is my vector A. Oh my, let's just pretend that's a straight line. Let's say this is my vector A, and this is the x-axis. See this 51.3 degrees? It's the angle between the vector and the x-axis. So it will be this angle right here. So let's just say that that's the angle, right? 53.1. Okay, so that's the magnitude and the direction of my vector A. But what if I told you we have to multiply this vector A by 2? What happens to the vector when I do that? Would the magnitude of the vector change? Would the direction of the vector change? Or would both stay the same? I don't know. That's what we're going to find out, right? So instead of finding the vector A, we're trying to find the vector 2A. So 2A just means 2 multiplied by vector A. Vector A, the column vector is 3, 4, right? So if I multiply this column vector by 2, I'll get 6, 8. How did I do that? 3 by 2 is 6. 4 by 2 is 8, right? See this 2 right here? This is called a scalar value. That's what we mean by scalar multiplication. So 2 is my scalar, 3, 4 is my vector. I multiply both of them, right? So this is what we call scalar multiplication. Right. So 2A is 6, 8. That's a column vector for 2A. Now we're trying to find out what exactly happens when we multiply a vector by a scalar. In this case, it's a positive scalar. Why did I say positive scalar? Because 2 is a positive value. It's positive 2. So what happens to the magnitude? What happens to the direction? So if I find the magnitude of 2A, remember, magnitude, square root, x squared plus y squared. The top number is always x, the bottom is y. So if I wanted to find x squared, that would be 6 squared plus y squared would be 8 squared. 6 squared is 36, 8 squared is 64. 36 plus 64 is 100. The square root of 100 is 10 units. So the magnitude of my vector is no longer 5 units. So the magnitude of the vector A was 5 units. But the magnitude of the vector 2A is 10 units. So what can we deduce from that? When the vector was multiplied by a scalar value of 2, So when I multiply the vector by 2, the magnitude also doubled, right? It went from 5 units to 10 units. That's why I have here, magnitude is twice that of vector A. If I ask you to find the direction now, you use the same formula, tan theta is equal to y on x. Y is my bottom value, so that's 8. X, top value, 6. Tan inverse of 8 on 6 would also give me 51.3 degrees. Notice, it's the same direction. 53.1 for my vector A, and also 53.1 for my vector 2A. So what exactly can we conclude from all this? Well, when a vector is multiplied by a positive scalar value, the magnitude is multiplied by k. K is the number, right? So in this case, 2. I said 2 is the scalar value. So whatever number we multiply the vector by, that's the scalar value. When the scalar value is positive, so scalar value is k, right? When the scalar value is positive, in this case, it was positive 2, the magnitude is multiplied by k. So just like we saw here, it went from 5 units to 10 units when my scalar value was 2. So that implies that this magnitude here was multiplied by 2. That's why the rule says that, right? So the magnitude is multiplied by k. 5 by 2 gave me 10. But the direction stays the same. The direction for both of them is 53.1. So that's what happens when you multiply a vector by a positive scalar value. Magnitude is multiplied by whatever that scalar value is, but the direction always remains the same. So what exactly would that look like? Well, let's say this was my vector A, right? If I drew it and all that, this is what A looked like. If I wanted to sketch 2A, notice it's still in the same direction. So it's pointing in the same direction. But this vector 2A is twice the length of vector A. So that's why we say the magnitude changes and the magnitude is multiplied by the scalar value. So that's why it's twice the length of A, but the direction stays the same. The arrowheads are still pointing in the same direction. Similarly, if I wanted to find a half A, so instead of finding vector 2A, I wanted to find a half A. In this case, k, my scalar value is a half. So what would happen? According to my rule, the magnitude is multiplied by k. So what does that mean? The magnitude of A would be multiplied by a half. Multiplying by a half is the same as dividing by 2, right? And that's why the magnitude of this vector, or the length of this vector, is a half the length of the vector A. But the direction stays the same. That's what happens. That's what happens when you multiply a vector by a positive scalar value. Do you understand that?
Yes,
No?
miss.
Yes, ma'am.
Yes, miss.
Thanks.
Yes, miss.
Cool. Okay, so that was a positive scalar value. What happens if we multiply by a negative scalar value? Well, the magnitude, it's still multiplied by k, right? So if I have what am I saying? If I have a vector A and then I multiply by minus 2A, yes, the magnitude is still multiplied by k, right? So it would still be twice the length of A. But in this case, the direction also changes. And when I say direction, I'm referring to the arrowhead. So for my vector A, it's pointing that way. But for minus 2A, so my scalar value is minus 2. Notice, yes, the vector is still twice the length of A, but the arrowheads are pointing in 2 different directions. This arrowhead is opposite to this arrowhead. And if I multiply this by a scalar value of -1, notice vector A and vector -A, same magnitude, so the length is the same, but look at the arrowheads. This one is pointing this way, but then this arrowhead is pointing up there. You good with that? I need to read this chart.
Yes, miss.
Yes, miss, understood.
Okay. Parallel vectors. Which one do I have? Okay, parallel vectors. Okay, no questions about that, right? The whole scalar
No,
multiplication thing, no?
No, it sounds pretty straightforward, thank you.
Okay. Parallel vectors. So vectors are parallel if they're scalar multiples of each other. So you see that vector A and 2A, they would be considered parallel vectors because they're scalar multiples of each other. If vectors A and B are parallel to each other, then A is equal to KB. An example, so remember K is the scalar value, right? Example, given two vectors A is equal to 2 minus 6, so this is the column vector for vector A, and then the column vector for vector B is 1, -3. Are these parallel? Let me go back to this. Parallel vectors are scalar multiples of each other. What do I mean by scalar multiples? Well, vector A has to be equal to some constant, vector B. Okay? So, well, A, looking at this, A, 2 minus 6, I can rewrite that as 2 multiplied by 1, -3, because 1 by 2 is 2, 2 by -3 is -6. And from this, we can now say, okay, vector A is the same as saying 2 by vector B. Because look, vector B is given as 1, -3, 1, -3. So A is equal to 2B. This is in this form. Since they are scalar multiples of each other, so A is equal to KB, these are in fact parallel vectors. Do you understand that?
Yes, miss. That's actually pretty simple, miss. I can't lie.
It is. No questions, right? I can move
Oh,
on.
miss, I do have a question.
Okay.
Can you
No,
have a
miss, I'm
negative
good.
scalar?
What?
Can you have a negative scalar?
Yes, you can.
Okay, miss, just checking.
That's what I just did just now. Magnitude and direction changes.
Just making sure, miss. Just making sure.
Okay, your turn. I mean, you could really just read this off and tell me. Are these the pairs, the vector pairs, are they parallel or not? C and D.
C and D are parallel. They look like they're related by a scalar factor of
Yes.
2.
2.
Mm-hmm.
Yeah, 2 in front.
If anybody does not see it, if you look at D, 4, 10 is the same as saying 2 by 2, 5. 2, 5 is C, and therefore I can say 2C is equal to D. So these are in fact scalar multiples of each other. S and T, are they scalar multiples of it? Well, are they parallel?
To me, no, miss.
Okay, I have one no. Anybody else?
Oh, miss. Which one? For number 1, right?
Number 2.
Or number 2? Not parallel in that way.
Okay, 2 for not parallel. 100%.
I don't believe that they're parallel because the ratio of the y component to the x component is no longer the same. So then when we do the inverse tan, we're going to get a whole different angle. The direction has definitely changed.
Mm-hmm. So yeah,
Oh, wait, for
these
real?
are not Somebody said something. Okay. And he just brought up something else, right? So I didn't put it in the PowerPoint for you because I've really never seen a question like that, but I feel like I should. Parallel vectors not only have the same, hold on now. Okay, sorry about that. Parallel vectors, yes, they're scalar multiples of each other, right? So that's the basics. That's what you're required to know for your exam. But there's another thing. If they're parallel vectors, then the ratios of their components should be the same. So let me just show you a quick thing. Like I said, I didn't include it in this PowerPoint because it's not really tested, but I've never seen it like that. You're just required to know, are these scalar multiples of each other? Yes or no. I never really asked about the whole ratio thing, but let me just show you. Parallel vectors, the ratios of their components are the same, right? So 2 and 4, those are my x components. So 2 on 4, this ratio should be the same as saying 5 on 10. So this is half. This would also give me a half. So since their ratios are the same, they're parallel. If I look at this now, the ratios of the x components, so that's 1 on 2. Okay, let me not put equal. And then 2 on 6. This is a half, right? And if I reduce this, I'll get a third. A half and a third, their ratios are not the same, and therefore these are not parallel. So just in case you want to know what in the world he was talking about, that's what he was talking about. Okay, are you ready, Kula?
Yes, miss.
I feel like I should include
Yes,
that
miss.
in the PowerPoint.
Yes, you can.
Let's move on. This is going by a lot faster than I thought. Addition of vectors. Suppose there are two vectors A and B. How do we find A plus B? Let me get this. Okay, let me not tell you. Right. So to find A and B, you have to combine vectors tip to tail or head to tail. What do I mean by that? This would be considered the head of the arrow, and this, looking at the red vector, the arrowhead, then looking at the blue vector, this tail right here. So it's always head, arrowhead to arrow tail, right? That's how you combine vectors. People who plan on doing physics, remember this. So this isn't necessarily true, right? But for now, when I say A plus B, I really mean traveling along the vector A followed by vector B. So let's say I'm starting here, right? Going along vector A, then going along vector B is the same as going from taking this path, then this path. It's the same as taking this straight path here, right? So think about it like, see this green vector here? Let's say you're on your way to school or work or something, and there's rail traffic, and you don't want to stay in that traffic, but you know some back road. So to avoid the traffic, you go to this back street, then you go to this back street, and you end up at the same position. So instead of going through all that traffic from here to here, you know the back streets, the back roads. So you go along A, then B, and you'll still end up where you need to be. Do you understand that?
Yeah, miss, I get that.
Yes, miss.
Yes, miss.
Yes, ma'am.
Crystal clear.
Nice, nice. So, continuation. An example. If you're given two vectors A, B, and BC, how do we find the vector AC? Well, AC is going to be equal to AB plus BC. So let me just sketch that real quick. Let me go on the whiteboard. Ooh, this is still here. That's nice. Clear all. What do you want this thing? Okay. So I want to find A, C, and they gave me A, B, and BC. I said AC is the same as saying AB plus BC. So let me just draw, well, sketch them. Starting at AB. So because I started with this A, this vector AB, it literally means I'm starting with vector AB, right? Let me just show you what I mean. We started with vector AB. So let's say, let me draw it in the same way I had the other one. So let's say this is AB. This is A right here. My starting point is A. Then I'm going to the point B. But I don't stop there, right? Because after AB, going along this vector AB, then I have to go along the vector BC. So starting from B, going to C. Going to C. So A to B, then B to C. But like I said, those are like the back roads. There's also this straight road right here from A to C. And this is actually called the resultant vector, right? Okay, we need to restart because I have less than a minute. So rejoin, right?